All right, guys, welcome back. It really feels like it's been a long time since we've done one of these. And the truth is, I wish I was there today that I could actually go through these notes with you in person. This is an area of math I really enjoy, and it's one that there's a lot of things I really want you to understand. So I'm going to try and fit all of that into a video that doesn't make you fall asleep. And we'll kind of go over some of these things tomorrow when I get back. But we're starting a new unit. We're talking about ratio, rates, proportions, and just to kind of start us off, really quick, we're going to make a couple of definitions here. And you can go write these in your vocabulary terms if you want, but for right now, I just want to put them right here on the paper. And that's really, what is a ratio? And a ratio, you've got the word right here, and up above it, if you just want to write, a ratio is a comparison. It's a comparison of two things. And that's it. What's kind of cool about ratios is I can compare anything I want. I can compare apples to bananas. I can compare oranges to bananas. I can compare watermelons to oranges. But out in the real world, they do a lot of comparisons that sometimes don't seem like they make sense. You guys have learned about some what we call rates, which we'll talk about here in a minute, like miles per hour, which is kind of weird that they compare how many miles you go in an amount of time. And that's just a special ratio. We call that one a rate because we're still comparing two things, but they have different units. So a rate is really just a ratio. It's just a special ratio. Like, for example, we can go back to, I can compare apples to oranges. Apples and oranges, obviously they're different things. One is apples, one is oranges, but you're still comparing fruit, or you're comparing something that's similar. But when we talk about rates, we're comparing two things that have different units, as in the way you measure them is what I mean by different units. Like, if I want to compare miles per hour, I'm comparing something that I measure with distance to something that I measure with time. Those are different units. So both of these are ratios, but this one we call a rate because we're comparing two things with different units. All right, and you've seen a lot of those. Miles per hour is one that I see every day when I'm driving my car. So that's the first one that comes to mind. But when you're out grocery shopping, you might see rates used when you're purchasing a certain amount of things. Like it might be, what is the cost per, well, we've already used apples. We'll go with something a little bit better. What's the cost per banana? Okay, you're comparing the price of something that we measure with money, to bananas, which you might count them or you might weigh them. It might be pounds. I don't know how you do it. But a rate, again, it's just you're comparing two different types of things. And a unit rate is just, it's still a ratio, it's still a rate, it's just a special rate. A unit rate, we're comparing two things, but the denominator is 1. What the second thing that we're comparing, like apples to oranges, a unit rate means that we're comparing apples to 1 orange, or how many miles per 1 hour, or what is the cost for 1 banana. So the denominator is 1 because we're comparing to 1. And we're going to get into how to find unit rates and different things, which you've done in 6th grade. So a lot of this is going to be review today. So 3 ways to write a ratio. And I've been doing some of this already. The first way that we write a ratio, the first way that we write a comparison is as a fraction, which is the one that you're going to see the most. So the first way to write a ratio is as a fraction. And let's just stick with miles per hour. So miles over hour. That's one way that we can write a ratio. Another way that we can write a ratio is we can use words, which isn't necessarily my favorite, but I can actually write miles per hour. And there's different words that we can use. There's different ways that we can say it, but that's another one that you're going to see quite a bit this year, especially in the story problems, which we're going to start seeing a lot more of from here on out. So the third way that we write a ratio is we use a special symbol. It's just a colon, so we can write it with, we can write it with a colon. I can do miles compared to hours. So let's pick some numbers. Let's say that I'm going, I go 120 miles in 3 hours. That's my comparison. I'm comparing how many miles I went to how long it took me. And I can use that in words. I can say that I went 120 miles per 3 hours. Or I can write it as a colon. I can write 120 miles, colon, 3 hours. 3 different forms, okay? And then this next little topic right here, 3 words that always mean divide. I hate that. I hate that it says always, because there's going to be a lot of people that know that's kind of the way you look at it, and they like to write questions that might use different words or might use those words in a different way. So I don't want, there's 3 words that usually mean divide. And you know, this year you can pretty much count on those words meaning divide, but you still have to be careful. You still have to make sure that that's actually what it means, okay? And the first word we've been using a lot, it's per, P-E-R. When you see that word, you can pretty much draw a fraction bar, and whatever's in front of the word is going to go on top, and whatever's after the word is going to go on the bottom, okay? So per is a big one. Another one that usually means divide is for. So I can say something like I went 120 miles per 3 hours, or I can say I went 120 miles for 3 hours of time. Or the other big one is the word in. I went 120 miles in 3 hours. Those 3 words, yes, they mean divide, but more importantly, what those 3 words are hints for, usually, is that you're comparing 2 things, which means you can make it a ratio, which means it turns it into divide. All right? So look for those words, per, for, and in, and they're hints that you're going to be using ratios or that you might need to divide something to get the answer. All right, so moving on. This hint, we're going to come back to it in just a minute here. One of the ways that we use rates a lot is when we're looking for, like this example. The example says, which is the best buy? Because you've got 3 choices. There's 3 cans of tennis balls that you could buy for $11.49. Or you could buy 6 cans of tennis balls for $16.79. Or you can buy 9 cans of tennis balls for $22.99. And this is one of those real world situations that you're going to have to come to a conclusion on your own someday, where you're trying to figure out which one of these, and it may not be tennis balls, you might be buying milk or bananas or socks or something else, but you're trying to figure out which one of these is going to give you the best price. And so what we're looking for when we're looking for best buy, and this goes back to the hint, is we're comparing the cost to how many cans of tennis balls that we're getting. And when we're looking for the best price, when money's involved, money usually almost always goes on top. So if you're looking for a better buy, you can assume that money goes on top of your ratio. So what I mean by that is when I'm writing a comparison, I want money to be what goes on top, which means the tennis balls are going to go on the bottom. Okay? I want to compare the cost, the money, to the number of cans that I'm getting, the number of cans of tennis balls. So what we're going to do in order to figure out this answer, if you're not already there on your own, we'll make sure it's in your notes so you have it just in case. But the first thing that we're going to do is we're going to set up a ratio in fraction form. We're going to set it up like a fraction for each of those items. All right, so my first one, and again, because I'm comparing money and cans, I could also compare cans to money, but when we're looking for the best buy, we want money per cans. So for the first one, I've got 3 cans of tennis balls for $11.49. it's really easy to just want to write 3 over 1149, but I want 1149 on top, and on the bottom, I want to put 3. And then I'm going to write a ratio for my next one. $16.79 is going to get me 6 cans. And then I'm going to write my next one. $22.99 is going to get me 9 cans. So I want to know which one of those gives me the best deal. And the way that we do that is we're looking for the unit rate. We're looking for the best price per can. But right now, I don't have price per can. Right now, I have price for 3 cans. And I want to change that to the price for 1 can. Or in other words, I want to take this denominator and I want to change it to the number 1. And which is a really easy thing to do. All you have to do is put this fraction in the calculator as a division problem. Okay, and when I do that, what happens when I put this in as a division, when I do $11.49 divided by 3, that 3 goes away because I'm dividing it away, and it just turns into a 1. So we're going to still write the answer using a fraction, or in other words, my answers are going to have a 1 on the bottom. So now I just need to do the division to see when I divide by 3, what does that change the top number to? So let's try this one. I've got $11.49, and I want to divide that by 3 cans because that's the cost of 3 cans. I want the cost of 1 can. So that tells me that I'm going to pay $3.83 for 1 can. And that's how I want to write my answer, $3.83 for 1 can. Okay, and now I want to do the same thing for 6 cans. So $16.79 buys me 6 cans, but I'm going to divide by 6 because I want the price of 1 can. And that gives me kind of a big decimal there, $2.79, but there's an 8 after, so I should probably round that up maybe to $2.80 because we're dealing with money, so we want to write our answers in cents. So let's move on to the 9 cans. I've got $22.99 will buy me 9 cans, and that gives me 2.554. Most stores are going to round up to 2.56, but we're going to use rounding rules, and we'll go ahead and round down to $2.55. So when I look at my prices, if I buy 3 cans, I'm paying $3.83 for each can. If I buy 6 cans, I'm only paying $2.80 per can. But if I buy 9 cans, I'm only paying $2.55. So the 9 cans is going to be my best buy, assuming that you want to buy 9 cans of tennis balls. That would be your best price. You're going to get spend the least amount of money for each can that you're buying. All right, so I know this is review. I know you've seen some of this stuff before, and I appreciate you hanging in there with me because these are things that I need you to understand, and I need to make sure that you understand. So we're going to do these couple problems together really quick. It wants us to find the unit rate, or in other words, it wants us to figure out when we turn the denominator into 1. So right now it's comparing 180 miles in 3 hours. It doesn't want 180 miles in 3 hours. It wants us to compare it differently. It wants to know how many miles in 1 hour, which can be a little bit confusing because I'm comparing miles and hours right now. But I could also compare hours to miles. So kind of the easiest way to figure out which one should go on top sometimes is to just read it. 180 miles in 3 hours. So what it wants is it wants miles in hours. So what I probably ought to do is put miles on top, 180 over 3 hours, and then I'm going to divide that like we put up here. I'm going to divide that to change the bottom into a 1. I don't want to know how many miles I went in 3 hours. I want to know how many miles I went for each individual hour. So in my calculator, I put 180 divided by 3. Hopefully you can do that one in your head, right? 180 divided by 3 is 60. So that means I went 60 miles in 1 hour. So that's my unit rate, 60 miles per 1 hour. So number 2, $9.60 for 4 pounds. So again, I could compare money to pounds, or I could compare pounds to money, but the way it's written, money comes first. So I'm going to write that first. $9.60 for 4 pounds. I don't want 4 pounds. I want 1 pound. So I'm going to put that in my calculator and divide by 4. $9.60 divided by 4 gives me 2.4. And we're going to talk about a pet peeve right here. 2.4. That's money. And I don't know what 2.4 means in money, but I do know that 2.40 means $2.40. So I'm going to make sure to put that 0. $2.40 for 1 pound. All right, and then the third one, 21 3/4 meters in 2.5 hours. Those are some ugly numbers, but we're still just comparing meters to hours. I'm putting meters on top, and I'm putting hours on the bottom. So on top, I'm going to put 21 3/4 over 2.5. And what it wants me to do is find how many meters in 1 hour. So I'm going to divide. I'm going to put 21 3/4 divided by 2.5. And I'm going to get 87 over 10, which isn't a very nice number. One way I could write this is, okay, that gives me 87 tenths. That's not, this 87 over 10, that's not my new ratio. That's just the top part. I could do 87 tenths over 1. 87 tenths though, that's, again, that's not a really nice number. In fact, I'm gonna turn that into a decimal, and that just becomes 8.7. And I would rather write it in that form, 8.7 meters in 1 hour. That looks a little bit better. That makes a little bit more sense than 87 tenths per hour, just so we don't have fractions on top of fractions. All right? Okay, number 4, still a unit rate problem, but it's actually giving us a little bit more work to do. It says that it costs $68 for 16 square feet of flooring. I'm just gonna go ahead and write that ratio right now. It costs $68 for 16 square feet of flooring. How much does it cost for 12 square feet of flooring? Well, right now I know the cost for 16 feet. If I wanna know the cost for 12, it'll help if I go back and figure out the cost for each one of those, because then I can just times it by 12. So I'm gonna use a unit rate. I'm gonna take 68 and I'm gonna divide it by 16, and I get $4.25. So it costs $4.25 for 1 square feet of flooring. But I don't want 1 square feet. I want 12 square feet. Well, that's easy to do. I just take $4.25, because that's the cost of 1, and I multiply that by 12. So I take $4.25, I multiply that by 12, and I figure out that it's going to cost me $51 for 12 square feet of flooring, which I could even write as a ratio, $51 for 12 square feet. All right, a lot of review there for you. Few things I need you to keep in mind. What you're putting on top, what you're putting on bottom. Be really careful that you're putting what it wants. If it wants dollars for pounds, you need to put dollars on top, pounds on the bottom. Okay, so I want you to give these 3 a try, or sorry, these 4. The first 3 are just unit rates, just like what we did over here. Make sure you set them up the correct way. Number 4 is kind of like our number 4 over here. It gives you the spread in 1/6 of an hour, and it wants to know how much it spreads in 2 hours. So think that one through. When you're done, bring your answers up, show the sub what you did, and if you got them right, they'll give you the practice. Good luck.